All right, so I just wanted to review the concepts in Unit 5 with you. So in Unit 5, you're learning about solution chemistry. So solubility. Solubility is a measure of the maximum amount of solute that can be dissolved in a given amount of solvent to form a solution. So it's really important to understand that basically we have three things here that we're looking at. We're looking at solvent, solute, and solubility. So let me give you an example. So let's pretend like you are making Kool-Aid. So the solvent would be the thing that is in the greatest amount, and so that would be water. And the solute would be the thing in lesser amount, which in this case would be the Kool-Aid. The solution would be the Kool-Aid mixture. So solubility would be how much of that Kool-Aid dissolves in that water. All right, so there's two types of solutions that you learned about. There are electrolyte solutions and non-electrolyte. So basically the difference between these two is that electrolyte solutions conduct electricity, whereas non-electrolyte solutions do not conduct electricity. So there are a couple of types of electrolyte solutions. Ionic solutions are electrolytes because basically if you have a salt and it dissolves in water, it is an electrolyte. Water is considered a non-electrolyte because it does not have any ions in it, and so it's important to understand that in order for a solution to be an electrolyte or to be able to conduct electricity, it has to have ions in solution. All right, so when we talk about solubility, there are a couple of things that we have to look at. So first of all, we look at temperature. So actually the higher the temperature, the more things dissolve. And so we can see that like when we're cooking something, if we heat something up, it's more likely to dissolve than if it's cooled down. And so temperature, an increase in temperature usually means an increase in solubility. There's three types of solutions that you learned about. There are saturated solutions, unsaturated solutions, and supersaturated solutions. So a saturated solution is one that has the maximum amount of solute dissolved in it. An unsaturated solution has less than the maximum amount of solute, and then a supersaturated has way more solute than solvent. So let me give you an example of each. So a saturated solution would be if I have an equal amount of solute and an equal amount of solvent. So let's pretend like I'm making sugar candy. So as I have 2 cups of water and I've added 2 cups of sugar, and basically that would be a saturated solution. Now it becomes supersaturated when I add way more sugar than there is actually water in there. And if you've ever made sugar candy, then you would know that that's actually what happens. You have to add a whole lot of sugar in there in order for that sugar candy to crystallize. And an unsaturated solution just means you have a small amount of solute compared to solvent. So if I have like 1 cup of sugar for 3 cups of water. All right, so when we talk about solutions, we can measure how much solute is in there based on what's known as concentration. So the concentration of a solution tells us the amount of solute per solution. And so when we look at this, we can talk about a dilute solution, which means there's a very small amount of solute, or we can talk about a very concentrated solution where there's a large amount of solute. So maybe you've bought orange juice in the grocery store and you've bought it in the freezer. So when you buy it, it says concentrated, and that's because you have to take that frozen orange juice and add it to water in order to dilute it. So if you just drank that orange juice without adding water, it would probably be really yucky. It'd be very strong because there's a lot of orange juice. In chemistry, the way that we represent concentration is what's known as molarity. So we talk about moles of solute versus liters of solution. All right. So another thing we can talk about is mass percent. So the mass of the solute divided by mass of solution, or we can talk about volume percent, which looks at the volume of the solute divided by the volume of the solution. All right. So another thing that we can talk about when we're talking about solutions is colligative properties. And colligative properties are any properties that change based on a liquid substance as a result of dissolving it. So an example of this is when during the wintertime when we have a lot of ice on our sidewalks, we add salt. Why do we do that? It's because the freezing point of water changes when we add that salt, and so therefore it makes that melt at a lower temperature. And so we call this freezing point depression. And so this is an important concept that we can use. Basically, we can change the properties of a solution by adding a solute to it. And so like I gave the example of salt on sidewalks. Another example of this is boiling point elevation. So instead of just adding water to your car's radiator, you actually add what's known as glycol or antifreeze. And so what that does is that actually raises the boiling point of the water. And so basically your car can get hotter and it's not going to blow up. Another type of colligative property is vapor pressure lowering. And so basically by adding a solute to a solvent, we can lower the vapor pressure so it doesn't vaporize as quickly. And this can be important when we're talking about boiling liquids. All right. So let's go ahead and talk about a specific type of solution. Now we're going to look at acids and bases. So in your lesson or in your unit, you learned that acids are sour and they're caustic. They are actually really good electrolytes. And if you combine them with cabbage juice, they're going to change color. And so actually they turn a really bright red for the strongest acid, and then like a purplish color for a little bit weaker acid. Bases, on the other hand, are actually the opposite of acids. They are actually very slippery, and they are also very good electrolytes, and they actually turn a yellowish and a greenish color in the presence of cabbage juice. And a really good example of a strong base would be liquid plumber. So when we talk about bases and acids, we have a couple of different definitions. Arrhenius came up with an acid-base definition. Basically, he says that an acid is any substance that gives away a hydrogen ion to solution. And so these combine with the water in the solution to form a hydronium ion, which is H3O+. So an example of an Arrhenius base would be anything that would donate that H+. According to Bronsted-Lowry, an acid is a proton donor and a base is a proton acceptor. And so it's kind of similar. So basically it's giving away that hydrogen ion, but then the base would be the thing that would be receiving that hydrogen ion. So if you look at this example, we have an acid, and the acid is basically giving away its hydrogen, and whatever's receiving that would be considered or whatever's left after that would be considered the base. So in this example, the acid is water and the base is OH-. All right, so acids can be either strong or weak. So a strong acid is like sulfuric acid, hydrochloric acid, nitric acid, perchloric acid, and you notice that all of these have an H to donate. Now weak acids would be like acetic acid, carbonic acid, phosphoric acid, and you can see that these ones have more than one H to donate. Now the difference between a strong acid and a weak acid is that strong acids completely dissociate in water and weak acids do not. So weak acids tend to stay together. All right, so let's go ahead and look at what that means. So here we have a strong acid, HCl, and we have a weak acid, H2CO3. So you can see that the H and the Cl actually break apart, whereas in the weak acids, some of them break apart, but some of them stay together. All right, so strong bases are pretty much the same as a strong acid as far as definition. Some examples of strong bases would be sodium hydroxide, which we find in drain cleaner, magnesium hydroxide, and aluminum hydroxide. Remember that strong acids and strong bases are very good electrolytes, so that means that they're very good at conducting electricity in solution. And some examples of weak bases would be like ammonia, HCO3- and HPO4. All right. So the way that we can neutralize an acid or a base is by adding them to each other. So in this example, we have sorry, that wasn't a very good example. Here's a good example. We have hydrochloric acid and sodium hydroxide, and when we combine them, they form water and then a salt. So remember that whenever you add a strong acid and a strong base, they form water and a salt. And so that's how we actually neutralize an acid or a base, is by adding either a strong or sorry, by either adding an acid to a base or a base to an acid. All right. So the way that we can indicate the presence of an acid or a base is by adding an indicator. And so an indicator is just some kind of chemical that changes color in the presence of an acid or base. So I introduced you to an example of that earlier. That would be cabbage juice. Cabbage juice changes color in the presence of an acid or a base. So here's some different indicators that are common in chemistry. You can see that they're based on pH. So if I was trying to find an acid that was between 0 to 1, I would want to use methyl violet. If I was trying to find an acid or a base that was between 2 and 8 pH, I would use thymol blue, and so on. So it really is based upon what the pH that you're looking for. All right. And so then the very last concept that we're going to look at are buffers. And so our body actually, even though we add acid and bases to our bodies all the time by drinking pop or eating fruit or whatever, our bodies are actually able to maintain a constant pH because we actually have what's known as buffers. And so a buffer just basically, when an acid or a base is added, it just maintains that similar pH. All right, well, that was it for the Unit 5 review. If you have questions, please let me know. Thanks.